Hello, everybody. So we're going to continue with lesson 1.4 today in the 5th grade Go Math textbook. We are on page 17. So powers of 10 and exponents. And so our question today is, how can you use an exponent to show powers of 10? Well, let's look at the unlock the problem. So expressions with repeated factors, such as 10 times 10 times 10, can be written using a base with an exponent. The base is the number that is used as a repeated factor. The exponent is the number that tells how many times the base is used as a factor. So in the example at the top, 10 times 10 times 10, there's 3 factors of 10. So the base is 10. That's the number that's the factor that's being repeated. And the exponent is 3 because there were 3 tens. And that equals 1,000. So in word form, you would say the third power of 10. In exponent form, you write 10 with the 3 raised. So now in the activity, we can use base 10 blocks to show this concept. So what is 10 times 1,000 written with an exponent? Well, let's break that down. If we only have 1 has a value of 0, the 0 power of 10. 0 power of 10 is just 1. If we have 10 ones, we'd have the first power of 10. We'd have 110. If we have 100 ones, we would have that 1 times 10 times 10, or the second power of 10. If we had 1,000 ones, it would be 1 times 10 times 10 times 10, or 10 to the third power, or the third power of 10. So how many ones are in 1? 1. How many ones are in 10? 10. How many tens are in 100? There's 10 tens, right? How many hundreds are in 1,000? 10 hundred. How many thousands are in 10,000? 1,000, 2,000, 3,000, 10. So in the box at the right, let's draw a quick picture to show 10,000. So it says use a box with the T in it for 1,000. Okay, well, that's 1,000. 2,000. 3,000, so on, right? Until we get to 10,000. 5,000. 6,000. 7,000. 8,000. 9,000. 10,000. So 10 times 1,000 is what? So let's look at that. 10, 100, 1,000, 10,000. So how many factors of 10 did we have? We have 4. And we'll start to notice a pattern that 10 to the 4th tells me that there are 4 zeros after the 1. So 10 times 1,000 is 10 to the 4th. Because 1,000 is 10 to the 3rd, and one more 10 is 10 to the 4th, or the 4th power of 10. All right, so let's look at some more on page 18. Multiply a whole number by a power of 10. So hummingbirds beat their wings very fast. The smaller the hummingbird is, the faster its wings beat. The average hummingbird beats its wings about 3 times the third power of 10 times in a minute. How many times a minute is that written as a whole number? Okay, so let's start with 10 to the 0 power of 10. Well, we said the 0 power of 10 is just 1. So 3 times the 0 power of 10 would be 3. 3 times 1. Okay, the 0 power of 10 is equal to 1. 3 to the first power of 10. Well, that means we only have 10 repeating itself one time. And so 3 times 10 is 30. 3 times the second power of 10. Well, this time we notice that there are 2 10s repeating, right? The second power of 10 is 10 times 10, or 100. 3 times 100 is 300. Let's see if we start to notice a pattern here. 3 times the 0 power of 10, there were no 10s. So we just had 3. The first power of 10, we had 1 10. In the second power of 10, we have 10 times 10, or 2 zeros in our product. So what do you think is going to happen when we go the third power of 10 and multiply by 3 10s? Well, we're going to have 3, and 10 times 10 is 100, times 10 more is 1,000. So you notice the pattern? We kept adding 1 extra 0 every time our exponents increased by 1. So what patterns do you see? The number of zeros. Oh, wait. So the average hummingbird beats its wing about 3,000 times a minute. Now, what pattern did we see? So we talked about this. We said that the number of zeros written after the whole number the number of zeros written after the whole number match the number of exponents, the number in the exponent. Okay, so the number of zeros written after the whole number matches the number in the exponent. Let's see if that's true. So here, our whole number is 3, and there are zero. The 0 is in the exponent, so there are no zeros. Here we have 3 as the whole number, and it says there's 1 as in the exponent, and there's 1 0. Here we have 2 in the exponent, and we have 2 zeros. Here we have 3 in the exponent, and we have 3 zeros. All right, so that's a reasonable pattern. Right? We can work with that. So number 1, share and show. We have 10 times 10. So what's the exponent form? Well, the repeating base is 10. And how many 10s? 2. So that's the second power of 10. the second power of 10. And the next one we have 10 repeating 4 times. So our base is still 10. That's the number that's repeating. And there are 4 of them. And so that would be the fourth power of 10. By the way, we can practice writing what those answers would be, right? The whole number is 1, followed by 2 zeros. Here, the whole number is 1, followed by 4 zeros. So 10,000. These are not needed parts in parentheses because it's just said exponent form. But I want you to recognize that 10 squared equals 100, 10 to the fourth, or the fourth power of 10 equals 10,000. All right, so find the value of the second power of 10. Well, okay, well, we just did that. 10 to the second power means 10 times 10, and 10 times 10 equals 100. So the second power of 10 equals 100. 4 times the second power of 10. So we'd have 4 times 10 times 10. Well, 4 times 10 is 40, and 40 times 10 is 400. But if we were just using patterns, I would just write the 4 followed by 2 zeros. So on this one, if we just look at the pattern, it would be 7 followed by 3 zeros. Because it's 7 times 10 times 10 times 10. 10 times 10 times 10 is 1,000. So 7,000. All right, number 6, page 19. So here we have 10, and it's repeating 3 times. So the third power of 10, which is 1,000, okay, is 1 followed by 3 zeros. The word form would be the third power of 10. Okay, number 7, I see 10 times 10 times 10 times 10 times 10. That's 2, 4, 5 repeating 10s. So it's going to be the fifth power of 10. And 10 to the fifth power of 10 would be 1 followed by 5 zeros. So 100,000. All right, find the value of 10, fourth power of 10. So that would be 10 times 10 times 10 times 10. That's what 10, the fourth power of 10 means. Well, the answer would be 1 followed by how many zeros? It would be the same number of zeros as in the exponent. There's 4. So 1, 2, 3, 4. 10,000. 2 times 10, third power of 10. So that would be 2 times 3 tens. So our answer based on the pattern, remember, is the whole number followed by the same number of zeros as in the exponent. There's 3 in the exponent, so the whole number is going to be followed by 3 zeros. So 2,000. So 10 times 10 times 10 is 2 times 1,000. All right, 6 times 10 to the 4th. So that means 6 times 10 times 10 times 10. So it would be 6 followed by 4 zeros. 10 times 10 is 100. Times another 10 is 1,000. Times another 10 is 10,000. So 6 times 10,000. All right, so complete the pattern. This is kind of like the hummingbird problem, right? So 7 times the 0 power of 10 just is 7 times 1. 7 times the first power of 10, we're going to have 7 followed by 1 0. 7 times the second power of 10, or 7 times 100, so it would be the whole number followed by 2 zeros. 7 times 10 to the third, 7,000. 7 times 10 to the fourth, it would be 7 followed by 4 zeros, because 10 to the fourth is 10,000. Number 12. So what's another way of writing 9 times the 0 power of 10? Well, we know that 0 power of 10 is just 1. So that's the same as saying 9 times 1. 9 times the first power of 10 is 9 times 10. The second power of 10 times 9 is 9 times 100, which would be 900. 9 times the third power of 10 would be 9 times 1,000. So again, we should be noticing a pattern. 10 to the 0, there are any zeros following the whole number. The first power of 10, there's 1 0. The second power of 10, 2 zeros. The third power of 10, 3 zeros following the whole number. And 9 times 10 to the fourth would be 9 times 1 followed by 4 zeros, or 10,000. And 9 times 10,000 is 90,000. All right. 12 times the 0 power of 10. The 0 power of 10 is 1, so 1 times 12 is 12. 12 times the first power of 10 is 12 times 10, or 120. 12 times the second power of 10 is 12, followed by 2 zeros. 12 times 10 to the third is 12 times 1,000, or 12 followed by 3 zeros. And 12 times the fourth power of 10 will be 12 followed by 4 zeros, or 120,000. All right, 14. 10 to the third equals 10 times the nth power of 10. What is the value of n? Well, we're saying that the third power of 10 is equal to this situation. Well, that means I have 3 10s repeating. Well, I have 1 here. So how many do I need to add or multiply by here? Wouldn't I need 2 more 10s? So again, it's telling us, think of 10 to the third as 10 times 10 times 10, right? Okay, 10 to the third power of 10 means 10 repeating 3 times. Or 10 times 100, because 10 times 10 is 100. So what exponent or what power of 10 equals 100? 2, right? So this problem would be 10 times the second power of 10, which would give us 3. 3 tens. 15. Explain how to write 50,000 using exponents. Well, what is 50,000? 50,000 is 5 times 10,000, right? So how can we write 10,000 as the exponent or as a power of 10? All right, well, we know that 10,000 is 10 times 10 times 10 times 10. How do I know that by just looking at 10,000? Because I see 1 followed by 4 zeros. So there has to be 4 tens. All right, so now let's put those two things together. So 50,000 is 5 times the fourth power of 10. Page 20. Lake Superior is the largest of the Great Lakes. It covers a surface area of about 30,000 square miles. How can you show the estimated area of Lake Superior as a whole number multiplied by a power of 10? Okay, so that's our question, right? What are you asked to find? Show 30,000 as a whole number multiplied by a power of 10. So 30,000 as a whole number multiplied by a power of 10. So how can you use a pattern to find the answer? So we're going to be looking for the product of a whole number and a power of 10 that equals 30,000. And we can use the pattern of like 3 times the 0 power of 10, 3 times the first power of 10, 3 times the second power of 10, so on, until we get to 30,000. So let's start that. So 3 times 10 to the 0 power of 10 is 3 times 1, or 3. 3 times the first power of 10 is just 3 times 10, which will be 30. 3 times the second power of 10 is 3 times 100. Second power of 10 is 10 times 10, or 100. So that's 300. So 3 times 10 to the third power of 10 is 3 times 1,000, which is 3,000. And 3 times the fourth power of 10 is 3 times 10,000, or 30,000. So the estimated area of Lake Superior is 3 times the fourth power of 10. And 17. The Earth's diameter through the equator is about 8,000 miles. What is the Earth's estimated diameter written as a whole number multiplied by a power of 10? So let's use the same idea that we just did. So let's start with 8 times 10 to the 0, or to the 0 power of 10. And that would be 8 times 1, which is 8. 8 times the first power of 10 is 8 times 10, or 80. 8 times the second power of 10 is 8 times 100, which is 800. 8 times the third power of 10 is 8 times 1,000, or 8,000. Okay, so that's how the pattern would look. But I also know that this number is the same as saying 8 times 10 to the third power, because there's 3 zeros following the whole number. So 8 times the third power of 10. And 18. Yolanda says the fifth power of 10 is the same as 50, because 10 times 5 equals 50. What was Yolanda's mistake? Well, okay. Isn't she multiplying the 10 and the exponent? Okay, so she looked at this and said, oh, 10 times 5, that's 50. But she should have been multiplying 5 groups of 10. Okay, so that's what she should have been doing, is multiplying by 5 groups of 10, which would have given her 1 followed by 5 zeros, or 100,000. Okay, so that's it for lesson 1.4. In our next lesson, we'll be working with multiplication patterns. So until then, I will see you soon.